this particular lab involves taking measurements. And when you take measurements, you have to know the calibration of the measuring device. Because if you don't know the calibration of the measuring device, you're going to take an incorrect measurement. For those of you in my lecture class, remember I told you the story about the cab driver in Egypt and how he was telling a more precise information than the information that he has? Well, that's the thing to avoid in this particular class. When you use a ruler and you measure, for example, the height of this particular marker, you don't want to say 9.6785 centimeters, because your ruler is not going to measure it to that precision. At the same time, you're not going to say 9 centimeters, because your ruler provides better precision than that. Okay, so what I want to do real quick is just give you guys a yardstick. And remember that we are studying the metric system. So do not be like my previous class in the past and start measuring everything in inches. Okay? That you would get a big fat X if you do that. We're measuring everything with the metric system. So if you take a look at that ruler, it happens to be a meter stick, which means that it's a meter long. And if you take a look at the side that reads centimeter, you will see that there are, it goes from 0 to 10 to 20 to 30 to 40, all the way to 90, and then they don't show 100. But each of those segments is a decimeter. It's 1/10 of a meter. Okay? And if you take a look at what the decimeter, and you look at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, each of those is a centimeter. So there's 1 centimeter, 2 centimeter, and then below that there's even finer calibration. So right now we have a meter stick, and that's 1 meter long. And this thing is split up into 10 segments. And each segment is a decimeter. A decimeter is basically 1/10 of a meter. And each of those decimeters is broken up into 10 segments. And each segment here is a centimeter. And then each centimeter is broken up into 10 segments. And that's the important part right there. I can't draw that kind of calibration, but you should see 10 lines between each number. And that's a millimeter. Each of those is a millimeter. Okay? The smallest calibration mark on your ruler is 1 millimeter long. So delta in your ruler is 1 millimeter. Or how many centimeters? Not 10 centimeters, but each one of these is from here to here it's 10 centimeters. So for one of these guys, if we blow it up, okay, it would be 0.1 exactly. Each one of this would be 0.1 centimeter or 1/10 of a centimeter. Thank you. 0.1 centimeter. Now this is important. Before you start any measurement, you want to look at the finest calibration of that measuring device. And in this particular case, it's 0.1 centimeter, because the precision of this particular ruler now is going to be to the 100th of a centimeter. It's always 1 decimal point over from the smallest calibration. So the fact that your smallest calibration is 0.1 means that you're reading this ruler to 100th, or 0.01 centimeter. Okay? So all your measurements today, when you're reading a measurement, better be to 100th of a centimeter. Don't just say 5.6 centimeters. You have to say 5.60 or 5.65 or 5.62. Don't just say 5.6, because that's the precision of this particular ruler. And you guys are going to be using these rulers in your measurements. Okay? So that's the first part. The other part is a thermometer. You guys are going to measure the temperature of the water. You're just going to fill a beaker with water, and then you're going to take a thermometer. Don't shake it down. You don't need to do that. Okay? Just take your thermometer and place it in that beaker. And when you do, let it equilibrate. Let it settle for about 15-20 minutes. And then after 15-20 minutes, you can read the temperature. In terms of the thermometer, this is the calibration. Here's my thermometer. And on one side, I see 10. I see 20. I see 30. And between each of these, and these are degrees Celsius, between each of these marks, I can see there's a halfway line here. And there's 1, 2, 3, 4. 1, 2, 3, 4. There's 10 marks between the 10 and the 20. So the question is, what is delta for this particular thermometer? Is it 0.01 degrees, 0.1 degrees, 1 degrees, or what? What do you think? So delta is, I'll give you a choice, 1 degrees, 0.1 degrees, or 0.01 degrees. In other words, what is the distance between this and this? If this is 10 and this is 20, then that is 11, right? So each delta is 1 degree. It's a 1 degree increment. So when you use this thermometer, you should measure it out to the 10th of a centigrade, 100th of a centigrade, or what? It should be to the 10th. So what you want to do is make sure all your measurement is to the 10th, 1 decimal point over. Okay, so that's the thermometer that you guys are going to be using here. Now, what you guys are going to do is just stick it in the water and let it settle, and then read the temperature later on. As far as your volumetric flask, I mean your graduated cylinder. Okay, this is the third items that you guys are going to be using. Types of graduated cylinder. We have a 100 milliliter graduated cylinder. We have a 25 mil graduated cylinder. And we have a 10 mil graduated cylinder. Now, they all look the same size, but that's because I want to magnify it. Okay. If you look at the calibration in the graduated cylinder, I will see that there's 70 here. I could start anywhere, preferably not at the bottom, but somewhere in the middle. And then the next major line is up here at 80. It goes from 0 to 100 to the top. But the big lines, 70 to 80, and then if I look at the finer calibration, I can see that there are 5 marks here. And so if you take a look at this diagram, what is delta for the 100 milliliter graduated cylinder? If this is 70 and this is 80, then the distance between here and here is what? 1 milliliter, right? So when you read the graduated cylinder, the 100 milliliter graduated cylinder, you want to read it to the 10th of a place. Okay, you want to read it to the 10th of a place. Because if you have a meniscus that is like this, you want to get an eye level to that meniscus, so you have to bring this graduated cylinder right at eye level. Make sure that you're totally horizontal. Make sure that the lines in the front of the graduated cylinder match up with the lines in the back, because if it doesn't, then you're going to have some error. And then you want to read the bottom of the meniscus. You want to read the bottom of the meniscus, okay? And so this would be estimated as 70, 71, 72, 73, 74, between 74 and 75. Okay, so you know it's 74 point something. And that point is your error, is your uncertainty. That's your estimate. Now it looks like it might be halfway, so I would read this as 74, those are the certain values, 0.5. Because that's the estimate. I could have also read this as 74.4 or 74.7, but this is the error in the measurement. That's why I'm reading it to, that's why I have to look at my calibration, because it tells me how far I need to read this measuring device. Okay? So, again, that last number is an estimate of where you think that bottom of the meniscus lies between 74 and 75. And I say it lies in between. But you might have a different take on that. Okay. In terms of the 25 mil graduated cylinder, this is a bit tricky. Okay. For this particular cylinder, we have 15 here, and we have 13 here, all the way up to 25. 15 and 13. So over here, which doesn't have a number, we know it's 12. It's going to be in between that. Okay, and then there's 5 marks in between. Like that. So this is, sorry, I got that backwards. This is 13, this is 15. And this would be 14. Not 12. Okay. 13, 15, and then there's no 14 here. Does it by 2s, but you can think that 14 is here. So if this is 13, this line right here is 13, this next line would be 13.1? 13.2, exactly. So delta in this particular measurement is 0.1. Sorry. Delta in this particular measurement is 0.2. Whenever you have a number that's not 1, but 0.2 or 0.5, then the error is still to the 100th, still to the 100th of a place, except this last number now can only be 5 or 0. It can only be 5 or 0. Now let me explain. Suppose I have a reading. This is the most difficult measuring device to use because it's not by tens, it's by 2s. But let's take an example. Suppose I have this. Okay? Suppose I have this. Now, if you take a look at this particular item, you can see that it's 13, 13.2, 13.4, 13.6. Okay? And it's either on the mark or halfway in between the mark. If it's on the mark, like this one, I would say 13.60. If it's anywhere in between, say it's like this, and the reason why you can see it better here is because it's blown up, but let's say it's in between the mark, then I would say 13.65. Okay? It's not 13.63, it's not 13.62, it's 13.65. When you have a 0.2 error here, then it's plus or minus 0.05. Plus or minus 0.05. It could be 0 or it could be 5. Okay? So remember, when you are reading the 25 mil graduated cylinder, your very last digit should be to the 100th of a place, and your very last digit should either be a 0 or a 5. Okay? This is one of those weird exceptions that we've been talking about in class. The last one is easy, because it's a 10 mil graduated cylinder. If I see here that this is 7, and this is 8, and I have 10 calibrations here, so each of these calibrations is 0.1 exactly. And so when I read a volume using this 10 mil graduated cylinder, I would read this to the what place? To the 100th of a place. Okay, so we're back to the only one that's difficult is the 25 mil graduated cylinder. Okay. The last measuring device that you guys are going to be using is the scale. And again, when you make sure you turn on the scale, and you're going to be like weighing a pencil, for example, make sure you tear it. Tearing simply means to zero the scale. So it reads 0, and then just place the pencil on there, and then you're just going to read the mass. And the numbers that are on the scale are all significant. So just write down everything that the scale provides. In this particular case, it'll measure it out to the thousandth of a gram, 0.001. Okay? So, this particular lab is straightforward in that all you have to do is take measurements. But the key to this lab, and what I will be looking for when I grade this lab, is how well you use the measuring device. That is, are you reading it properly with the correct precision? That's the key. Okay, you guys are going to be graded on that. So, let me just go through the steps real quick so that you guys know what to do. This is found on page of your lab manual. This is found on page 111, right? First step, number 1, take a beaker of water, fill it up with water, stick your thermometer in there, and let it sit for about half an hour. Okay? The next thing you want to do is you want to go to a scale. If the scales are all being used, then don't go do that procedures. Do the next one, because we only have so many scales. You guys can go to the graduated cylinders. You can measure your height. You can measure the circumference of this 2-liter bottle. You can go to a different part, because you don't have to go do it in order. Okay? The next part is to take a pencil, and we already said that, weigh it. Take a 100 ml beaker, you want to weigh that. You take a 2-liter bottle, you want to weigh that. Between each weighing, you want to tear the scale so that it reads 0. And then finally, you want to take a look at your textbook. Don't weigh your textbook. Okay? What you want to do is, let's say that this is your textbook. You kind of get a feel for it. You know how much these things weigh. You know how much a beaker weighs in terms of grams. You know how much this thing weighs in terms of grams. Estimate the mass of your textbook. Don't weigh it, estimate it. You need to get used to the metric system, and so you want to estimate it. You could probably estimate that maybe your textbook in pounds is about 1.5 pounds, but how much is that in grams? You want to get used to thinking metric system. So you want to estimate it, okay? And then just write an estimate. There's no right or wrong answer, except if you're too precise. If you're going to estimate your textbook as 45.876 grams, then that's too much information, okay? It's an estimate, so you're going to estimate it to like 10 grams or 1 gram. You want to use the best figures to do that estimation. Don't be too precise, because an estimation can't be that precise. The next step is to measure length. That's where we use the ruler. Remember that when you use the ruler, you're going to use the centimeter scale, and it should be read to the 100th of a centimeter. You want to measure your height. The best way to measure your height is just stand against a wall, make a mark, and then take a ruler and measure how high that mark happens to be. Okay, that's the best way. You want to measure your foot. Just take a piece of paper or go to one of these tiles and put your foot in one of the edges, and then mark the end, and then measure your foot that way. Okay, use this ruler. That's the easiest way to measure your foot. And then measure the circumference of this particular 2-liter bottle. You could certainly try and take a ruler and wrap it around. These things are not flexible. The best way to do it is just take a piece of string. That's what the string is for. Cut a piece that is long enough to cut a piece that is long enough to tie, and then all you have to do is mark the sides where they come together, maybe with one of these magic markers, and then measure that length. So that's the easiest way to measure the. Now I have this to begin and this to end. All I have to do is measure that, and that would be the circumference of my 2-liter bottle. That's what the string is for, by the way. Okay. The next step after that is measuring the graduated cylinders. Back there are 2 sets. Make sure you label in your notebook which set you're measuring, the A or the B. These are the A series. They'll say 1A, 2A, and 3A. If you're measuring the B's, then write 1B, 2B, 3B's. But just keep to one set. Don't mix it. You want to measure the volume of this liquid based on the precision that we talked about. Okay? Remember, I'm telling you what precision to use so you won't get mistakes in your lab. Measure the volume of your 25 ml graduated cylinder. Measure the volume of your 10 ml grad cylinder. Then you want to estimate the volume in here. You have an idea of how much this volume is in this cylinder? Estimate that. Does it look like it's 5 milliliters? Does it look like it's 20 milliliters? Estimate it. And again, don't give me an estimate that is too precise. 10.876. That would be incorrect. Probably based on that. Okay, probably not even to the 10. Okay, so you're just going to estimate it. Again, it's to get you guys thinking in the metric system. Okay, when you're done with that, then go to the next page. And this is the last part of this experiment. What you guys are going to be doing is you're going to take one of these cubes. These cubes are either iron, tin, tungsten, what's the other one? Aluminum. Okay, so they're different metals. And what you guys are going to be doing is you're going to be measuring the density of this particular cube. You're going to do it in 2 ways. One is to measure the density by dimensions, by geometry. What you want to do is measure the height times the width times the length, and if you multiply that against each other, you've got the volume of a cube. Okay? Make sure you use centimeters, because when you use centimeters and you multiply centimeters times centimeters and centimeters, you've got cubic centimeter, which is what? A cc or a milliliter, right? So that'll give you a milliliter of this particular cube. The other way to measure the density of this particular cube is by water displacement. What you want to do is you want to take one of these graduated cylinders, take a note of the calibration of this graduated cylinder, read an initial volume. Then you want to take this, and that's why the string is here. You want to submerge it and read the final volume. The string is not going to be contributing to the volume. The string is very negligible. Okay? So you read the initial, you read the final. The difference is the volume of the cube. Okay? So you measure the density in 2 ways, by geometry and by water displacement. Before you do any of those volume measurements, you want to make sure that you measure the mass, and the mass for the 2 methods are going to be the same. Okay? You want to measure the mass first. The mass is going to be the same for both techniques. The only difference between the 2 techniques is the volume, or the method by which you measure the volume. One is by geometry, the other one is by water displacement. At the end, you're going to have different densities, okay, in terms of the numbers, and you have to explain why these numbers are not exactly the same. And they're not going to be exactly the same. They might be in the same ballpark, 8.7, 8.765, 8.76505, okay? But they're not going to be the same number. And you have to explain why they're not the same. And the reason is based on how you measured out the measurements, okay? At the end, when you're done with all that, you want to go to the next page, and you see in this worksheet on page 113, you've got a pencil. Write the mass of the pencil in grams there. Write the mass of the beaker in grams there. Write the mass of the 2-liter bottle. And then convert that to milligrams. So you start to do metric conversions in this particular page. For one of these, let's say the pencil, I want to see a calculation that takes you from grams to milligrams, from grams to kilograms, and from grams to pounds. Just the pencil. You don't need to show the others. Okay? But for the others, I want the answers. Okay? For the second part, the length, you want to write down from your data sheet the length of your height, your foot, and the 2-liter bottle. And then for this one, the one that's boxed, the 2-liter bottle, I want to see the calculation on the bottom. And then when you're done with that, you go to the volume, and you can see, again, you write down the volume of the 100 ml cylinder, the 25 ml cylinder, and the 10 ml cylinder. And then you convert it to liters, and then you convert it to gallons. And then for your calculation, I just want to see the 100 ml graduated cylinder calculation. Okay? So that's your lab for today. It's mostly measurements with a lot of calculations at the end.